Hi, I wanted to give you a quick walkthrough of how to use the Mira type debugger. So I'm going to run it here, having it compile the Mira compiler itself, and it's going to start up. Alright, and I'll let it start running in the background while I explain the screen here. So it gives us a few things, shows us variables of where it stopped. We can add breakpoints here. Up here we've got the stack of where we are right now. It's nowhere interesting, but if you were stopped in the middle of code, you could see all the places where it stopped. This is the parsed representation of the code. You can browse through here, and the original tab is the original source code that we parsed, complete with comments. If you look at this tab though, this is the AST turned back into something you can read. So this is particularly useful. You can see, for example, here's a macro that got expanded and you can see what's plugged in. And now we can see the compiler hit an error, and so it stops so we can inspect the state at this error. It can't find the method argument types on a variable called method. So if we look at the code here, well, let's see, let's look at the AST to figure out where we are. We're inside the method definition visit constructor. So find the visit constructor source. Alright, so we're right here, and we can actually tell from this source code here pretty well what the problem is. The method is supposed to be an argument to this method. It's supposed to be a local access. But we can see the parentheses here, it's getting treated as a method call. So my first guess here is that for some reason the type of method, JVM method, it's not finding that class, and so it's resolving it to a method call instead of a local, which, I mean, that's a bug in the compiler. There is clearly a local variable here, so it should be returning the error for that local variable instead of going on and doing the method call. But if we can tell here also that this variable is used a few times, and in the other places it's used, it is actually treated as a variable. So something else is going on here, which is weird. And we can see the same thing through exploring here. If we look at the first use of the method up here, we can see that its type is resolved. Oh, well, no, that's an error too. Oh, that's not. That's the error node. Sorry, the selected node type is resolved to JVM method. So it knows the class exists. Something weird is going on here. Why this node is resolving to the error. So we can look here. We're on line 249, call compiler.mira. Let's run it again, set a breakpoint there, and see what's going on. Alright, so now let's let it run. Alright, So we've stopped on line 249. I'm going to get rid of this breakpoint because I don't necessarily want to stop at all the other nodes that are on that line. And I'm going to step through, and you can see in the stack here which node we're on. We want to keep going until we get to the vcall, which is going to be the access to the local variable. And now let's keep going. Okay, it's testing out the local access, but if we look at this, alright, it's resolved the type for the local access to a local future. But right now, the local future is resolved to an error. It can't find the class yet. It doesn't exist. So I'm going to add a watch on that future and let it keep running. Alright, so now we've hit the watch. We can see we're at an interface declaration. This is the declaration for JVM method. So now our local future has resolved from error type to JVM method. So now let's step through all the nodes that got updated because of that. So first, our local access. We're on line 247. So if we go back to the code, alright, so the method is called in 3 lines in a row. We went line 249, we're on 247. But I want to point out while we've got the AST up here, what's gone on here. This empty array was not here last time. This node replaced the call that was there, and it's causing this problem. So the original node we cared about got copied into the empty array, and the copy is not getting updated. We'll see. So we keep going through. Okay, we're at the next local access. Now when we get to local access on 249, the AST went crazy, right? The top of this is the call, not the script, because this AST that's now getting updated is not part of the class anymore. So we're updating the wrong node. We need to make sure that when we make a copy of this node, it knows that it should still be updated, when in fact we've already replaced it with the wrong node. So that's the debugger. So far it's mostly been useful for tracking down bugs in the Mira compiler, so I don't know how useful it will be to anyone else unless maybe you want to understand the internals of the compiler a little bit more, but there it is.